Here are the rest of the notes for the section 4.4 day 2 homework. So we're going to do example 7 and example 8. So graphing logarithmic functions without a calculator. So here in example 7 we have y equals log base 1/2 of x. Now whenever we're graphing logarithmic functions without a calculator, what we need to do is actually change our logarithmic form into exponential. So we need to change this into an exponent. Now, using the information you have learned so far, so changing from a logarithm to an exponent, our base in our new exponential form is 1/2. Now, we're going to take this to the y power and set it equal to x. Now, we are not doing the inverse, so do not switch your x and y values. Another thing is make sure your y is the exponent. If our exponent was x, we would actually be graphing an exponential function and not a logarithm. So make sure you make note on your note packet or whatever, okay, whatever you're writing on, make sure your exponent is always y when you're graphing logarithmic functions. Now, because we changed it into exponent form and our exponent is y, we're actually going to plug in values into y. And then we'll solve for our x. So we plug values into y. So we'll have x and then our y on our table. Now here what I'm going to do is use those 5 basic numbers, so -2, -1, 0, 1, and 2 for my y's. Now what I'm going to do is I'm going to plug these y values into our exponential. So for example, -2, I have 1/2 to the -2nd power. Now remember, negative means we're going to switch this from a fraction to a whole number, so 2, and then we square it, which should give me 4. So now my x is going to be 4. And I do the same thing with -1. So I have 1/2 to the -1st power. That should just change it into 2. So I have 2. Now plugging 0 in for y, remember anything to the 0 power should always be 1. Plugging 1 in for y, I get 1/2. And then plugging 2 in for y, I get 1/4. Now graphing, because we're doing a logarithmic function, remember our asymptote is now vertical. Okay, so now the default, since we don't have any translations, is going to be at x equals 0. So do not forget that for logarithmic functions, we have a vertical asymptote. Now I'm going to graph my points. Now make sure you graph your x, y. So we graph actually 4, -2. So I go over 1, 2, 3, 4, down 1, 2. Now I plot 2, -1. So 1, 2, down 1. Then 1, 0. 1/2, 1, so you're kind of in between here. And then 1/4 and 2. So now we connect the dots here. Do not forget your arrows, okay? This is a function that goes on forever, so do not forget that. So now that we've connected the points, I didn't do it so well here, but make sure your points are connected. We're going to figure out the domain and range. Now remember, domain and range of our exponential and logs, they reverse. So domain and range of our exponential now becomes the range and domain of our log. So we know that the domain of exponential is all real, so -infinity to positive. That means the range on our exponential is going to be all reals. So domain and range switch. Okay. There we go. So domain and range switch. Now for a domain, remember that is going to be our x values. Now here we're going to start at our asymptote. Okay, our asymptote is at 0. Remember with any asymptote we use parentheses. But now make sure, because here we're doing x values, we start at 0, and our x values actually become bigger. Because they're becoming bigger, we're going to use positive infinity. So your domain is going to be from 0 to positive infinity. Remember, if you need to pause the note so you can write down or go a little bit slower, make sure you do that. Okay, let's go ahead and go to our next one. Now, example 8, this is actually where we're going to use our translations, okay? Basically, our vertical and horizontal. Now, to do this, we're first going to graph the parent function. The parent function of our log here is going to be y equals log. Now, our base is 2, so base 2 of x. Now, remember, this x is not an exponent. Okay, it goes right next to our log. Now, in order to graph this, okay, we need to change this into exponential form. So make sure you change that. So change to exponential form. So here our base is 2, so we have 2. Remember, we take it to the y power and set it equal to x. Whenever you're graphing logs, make sure your exponent is always y, because we don't want to graph an exponential here. Okay, so now what we're going to do is we're going to take our xy table. And remember, we're plugging values in for y. So we're going to use -2, -1, 0, 1, and 2. Now, plugging -2 in for there. There we go. So now you guys can kind of still see it. So we have 2 to the -2nd power. Remember, this now changes the whole number into a fraction. So I now have 1/2 to the 2nd power. And that should give me 1/4. So I have 1/4 here. Now I plug -1 in for 2. So I have 2 to the -1st. So that changes it into a fraction. So I have 2 to the 1st power, which just gives us 1/2. Remember, anything to the 0 power always gives us 1. Now 2 to the 1st power gives us 2, and then 2 to the 2nd power gives us 4. Now, because I'm graphing the parent function, remember our default asymptote is going to be at x equals 0. So I'm going to draw a line at x equals 0. Remember, it's a dashed line to indicate that it is our asymptote. And it's at x equals 0. Now what I'm going to do is graph these points. So I have 1/4, -2. So I go to 1/4 on our x, go down 1, 2. Then I have 1/2 -1, so I go to about a half here, and then -1. We have 1, 0, so I go 1, and then I have 0. Down here it's 2, 1, so I go over 1, 2, up 1, and then 4, 2. So I go over 1, 2, 3, 4, up 2. Now I connect these points with my line. Make sure with your line you have arrows to indicate it goes on forever. Now what I'm going to do is use my translations to move this graph. Now notice we have x plus 3 plus 1. Here's my h value, here's my k. My h, because of x plus 3, remember, do the opposite. So that means I'm going to go to the left 3. Now k is exactly as you see it. So we're actually going to go up 1. So for every point that I plotted, I'm going to go left 3, up 1. Now, not only does my points change, but also my asymptote. Now, when we did exponentials, it was the y value that changed, okay, our horizontal. Now we actually have to use our x value, this left 3, to change the asymptote. So I'm going to move my asymptote 3 places, 1, 2, 3. So my new asymptote is now at x equals -3. So make sure when you do this, you move it using your x value, so left 3 here. Okay, so x equals -3. Now, let's go ahead. I'm going to change all my points. So let's take this point here. So I go over 3, so 1, 2, 3, and then I go up 1, so about here. Take the other one, 1, about here, yeah. So 1, 1, go 2, 3, there you go, and then go up 1, so that should be here. It's kind of hard to tell, but that's right there. Then I go over 1, 2, 3, and then I go up 1. Let's make sure I did that right. Oh, it should be right here. There we go. And make sure you count correctly when you're doing these, okay? I'm going to do this in a different color so you guys can see. So I have this here, then I have my half here. There we go. Now taking it this, we have 1, go over 1, 2, 3, and then go up 1 here. Take this point, go over 1, 2, 3, and up 1. I'm going to make these a little bit darker so you guys can see them. Connect your points. Make sure you draw your arrows to indicate they go on forever. So now the graph I have here is now in the green. So the graph of y equals log base 2 of x plus 3 plus 1 is the one in green. Now, not only did we have to graph the function, we also have to find the domain and range. We're finding the domain and range of our green graph here. Now remember, the range of our logarithm is all reals. So we go from -infinity to +infinity. Our domain in this case, we are going to start at our asymptote, so the black one here. So we start at -3, and because our x values actually get larger, so we start at -3, then we go from -2, -1, 0, 1, 2, 3, etc. Because the x values are getting bigger, we're going to +infinity. So our domain for this function is going to be from -3 to infinity. If you have any questions, make sure you email me or you come in before or after school to get help.